get started. I'm going to do that reminder myself here. I wanted to show everybody that on my WLC, I don't know how many of you looked at that, but the outline kind of the stuff we did is there. You've got some notes from class. By the way, I'm catching up on the videos. I had a marathon session last night. But and this weekend I hope to, well, I mean, it takes like, a marathon. I mean, I spent about 5 hours on it last night. And the problem is I got to stay on top of it. My goal is at the end of each day, by that night, I'll try to have up the video from that day. Well, now I'm behind, but I intend to catch up this weekend. But when you look at the individual lessons, you'll notice besides the outline and some notes from class, there's the assignments are all listed there. I forgot about, or at least these are. I haven't checked all the way down. So here's the assignment for today. No, that was one. Let's see if I agree with myself on the one you had for today. Is that right? 159 ... 81. And then for tomorrow, the every other odd up to 99. Okay. All right. So questions from 1, 2. And a quick reminder in my head. 1, 2 was all about, oh yeah, it was all the graphs. Okay, let's start on this side this time. Katie. 61? 61. Wow, you have popular approval for that, Katie. Find the points of intersection of the graphs of the equation. Use a graph. Okay. Use automation to check it if you want. Okay, what do we have here? Equations. Y equals x to the 4th. Minus 2x squared plus 1. And the other one is y equals 1 minus x squared. Okay, where might they intersect? Do you notice this is a perfect square trinomial? Anyway, that's x squared minus 1 quantity squared, but I'm just going to write that down because I think that might help us. How did I figure that one out? Because this is x squared squared, this is 1 squared, and then if you take the product of the two, negative 1x squared, and double it, you get the middle term. Anyway, how do you find out if where two curves intersect? No problem. Welcome, Matt. How do you find out where two curves intersect? You basically set them equal, right? So we set them equal. You know, I think I'm going to write it that new factored way. So let's just write x squared minus 1 squared equals 1 minus x squared. And isn't this there? Let's write it like that. Would that allow us to, did that help at all? Yeah, because now couldn't we divide both sides by x squared minus 1? And then this would be gone, and one of these would be gone, leaving us with, interesting, add 1 to both sides, take both square roots. Anyway, there is only, of course, 1 square root of 0. So where are we? We found one intersection point, at least if I did my work right there. What else are we supposed to do? I don't know. I'm just saying that's the one that appears from my algebra so far. There are other ways to do this, and I may have hidden them by doing the cancellation. So let me take a look at one more look at this problem. Okay, where are we? Right here. Let's do control clone. Okay, I'm just going to look at it another way now. Just one thing about factoring, sometimes you hide some things. Okay, let's just set them equal and see what happens. If we get everything on one side, it's supposed to be a plus. Let's see, we add x squared to both sides. We now have x to the fourth minus x squared plus 1 equals 1. And then x to the fourth minus x squared equals 0. And then we could factor. Yeah, here are other. So now you can set each factor equal to 0. That's the one we got before. But we also get this one. So now we wind up with 3. So something about some techniques, when you cancel, you can hide some other solutions. Now we're supposed to check automation to see if how this looks. So I'll just take a quick look here. X to the fourth minus 2x squared plus 1. Trying to make this smaller. Okay, so let's add a function here. X to the fourth minus 2x squared plus 1. Now let's add the other one. Okay, you can see that seems to confirm they're both the same color, sorry about that, but where do they cross? -1, x equals 0, and 1. So that makes sense based on our, you're supposed to check some kind of graphing utility to see. It does seem to corroborate that. So I should write the number up there on top so we can refer to that. Not much is going right today. I don't know what I did with my pen. Ah, yes. Extra credit, yeah, you bet. There's a guy digging away for what he can get. Okay, 61. Now, next. Wade, I think you had your hand up. 53. Complete the square to right. Yes, I'm glad you're picking one like that. Okay, 53. Supposed to use completing the square. We have 16x squared plus 16y squared plus 16x plus 40y and minus 7 equals 0. Does that look copied correctly, Wade? Thank you. Okay, let's get the what? Let's get 7 out of there. By the way, do you see how dividing or factoring out or dividing by 16, while it would solve 3/16s, it would create some kind of ugly creatures. So I don't know if it's the best or not. So I'm going to not do that this time. Anyway, I'll get 7 on the other side. Let's put the x guys together. And I'll put the y guys together. Okay, now, as I want to complete the square on these two guys, I should have left more space here. I need to factor out a 16, because you cannot complete the square unless you have a 1 sitting on the x squared. So, 16 times the quantity, x squared plus x, leaves space for the third term. Now, what are we going to do with this guy? We got to take out a 16, so I guess we're going to have to do the 16 thing anyway. Now we have what? 40 over 16, which is 5/4? No, 5 over 2, thank you. And then leave a space, equals 7. Now let's complete the square. I should shove that whole thing over just a little bit. Hang on just a second. Okay, got a little more room now. It's going to be tight. Okay, the b term on this one is 1. Half of 1 is 1/2. 1/2 squared is 1/4. What did I just add to the left side of the equation when I put that 1/4 in here? I added 16 times 1/4, which is 4, right? So I got to add a 4 to equalize it. On this side, half of 5/2 is 5/4, and 5/4 squared is 25/16. Okay, and that means I added 25 to the left side, right? Because 16 times 25/16 is 25. I ran out of space here, but I'm adding 25 to equalize it. Okay, this is now a perfect square right here. Just trying to write an x. That's 1/2 squared, and this is just y, not y squared. And then what do we have on the right? 32 plus 4 is 36. Okay, now let's get the 16s out of there. So I guess by not dividing by 16, we just put off the pain. We got to do it anyway. So we divide everything through by 16. And over here we get 36/16, which is what? I'll just leave it that way because it's easier to take the square root of that way. Okay, so now we know. Where's the center of the circle? First of all, you should see it's in the form of a circle. And what's the center? -1/2, -5/4. And what's the radius? The square root of this. So that would be what? 6/4, which would be 3/2. So I guess I could have just reduced this here too, couldn't I? Still could take the square root of it. So I think that was the object of the problem, wasn't it? Get the center. And completing the square twice allows you to do that. I take a follow-up to this? Go ahead.
On the right side of the equation, when you add 4 and 25, normally when you take a square, you add like the product of what you did with the middle term. So say like for the first part, you would add a quarter normally to the side. Why did we add 4 and 25?
Because when I added 4 here, Kyle, that's really, I mean 1/4. Isn't that in the big picture 1/4? Because it's in parentheses, that's 1/4 times 16, which really is 4.
Right.
And over here, what's 25/16 times 16? It's 25. That's the reason I added those. Anybody else a follow-up to this? Okay, now, next. Christy? Stuck on what? Okay, gotcha. Okay, let's do a new page. So we're looking at number 37, everybody. She said she got stuck on the x-intercept part. We were supposed to find what? Both intercepts or all intercepts? Sketch the graph of the equation. Okay, well, we'll just do the x-intercept. Let's see, we got x equals y squared minus 4. To get an x-intercept, what do you have to do? You have to set y equal to 0. So if you set y equal to 0, you get what did you want? The y-intercept? I know it isn't. I know. I thought she can't really want that. She can't really want that. Okay, so you meant the y-intercept?
I don't know.
So anyway, the x-intercept is -4, 0. Okay, the y-intercept, now you set x equal to 0 and solve for y. You're not going to think this one's very hard either, but that's okay. Anyway, so now you got two of them. It's 0, 2. It's also 0, -2. And so, that's all right. There are two y-intercepts and one x. Lindsay? 57? Okay, 57. Find the points of intersection, one of those again. X squared plus y squared equals 25. Lindsay, do you recognize what that is, by the way, just by looking at it? It's a circle, and center's at the origin, because there's no, x minus, no y minus. So origin's at the 0, and the radius is 5. Okay, and the other one is 2x plus y equals 10. So you can see that this is a line that probably intersects a circle on 2 points. Okay, how do you find out where two curves cross? You basically set them equal to each other. So we can't do that unless we solve for y, can we? So let's take that curve on the left and solve it for, well, this one solve for y is, and then the other one, now that they're both equal to y, we could set them equal to each other. And, get them all together, do what we can to solve for x now. Well, we'd probably want to square both sides. We got to get rid of that root. And what do we get on the right? That's one of those perfect square trinomials again. If we add x, let's get everything on the right. So we're going to add x squared, and we're going to subtract 25. So now, I'm sorry that's so sloppy, but now we could use the quadratic. We could, well, let's get the 5 out of there first. Doesn't look too factorable, does it? Oh, 5 and 3, yeah. What am I thinking? Okay, now we got the two values of x. X minus 5 equals 0, so x equals 5. X minus 3 equals 0. Were you supposed to find the y coordinates too? Okay, how do you find the y coordinates? Take whichever equation and, I mean, I'd use the linear. It's a lot easier. If x equals 5, what's the y coordinate? Negative 10 plus 10 is 0. So that point's 5 comma 0. And if x is 3, negative 6 plus 10. So according to that, those would be the two ordered pairs where, okay, maybe one more. I'm sorry, can't do them all. Yep.
Can we ask a question on this one first?
Yes, you can.
How did you get 4x squared minus 40x plus 100?
I had squaring both sides, Darnell. So I was taking this guy and squaring him.
Right, but where are you getting negative 40x?
Well, you want me to just do it the long way? Here, I'll tell you what I did, and then I'll do it the long way so I can prove it to you. Okay, what you do when you square a binomial is you square the first term. That's how I got this. You square the last term. That's how I got that. And then you take the product of the two, which is negative 20x, and you double it. But if you want, I can show you when you hammer it out, that's what you'll get.
Oh, that's not.
Yeah. So anyway, that's where that came from. Any more follow-ups to that one? Okay, remind me, what number was that? 77. What's going on 77? Okay. Use the graphing utility to graph the equation. Use the graphing utility to approximate the x and y intercepts. Well, okay. Okay, what is this thing? 71. I mean 77. 0.24x squared. By the way, the graphing utility I'm using is free. And it's pretty decent. Now, I know you may have graphing calculators, and that's fine. I'm just saying, if you wanted some software for your PC that would do this stuff, it's a good price. It's the only price I ever consider. There's so much good free stuff out there now. You can really do pretty well with mostly free software. But anyway, plus 1.32x. And then plus 5.36. Okay. Obviously, something's wrong. Let's see. There we go. Now, I forgot. We're supposed to approximate the x and y intercepts. Well, we don't have to mess with an x-intercept. The y-intercept, just zoom in and try to pick where. I don't know. What did you want to know? Well, you enter. Oh, I guess I'll have to do that. Maybe we'll have to do it after. But you got a y equals button on there. That's where you enter your equations. Now you got to remember to put an asterisk for multiplication, whereas I didn't have to up here. So you'd have to put in 0.24 asterisk. why don't we work on it? Yeah. If it says do it by a calculator, it's kind of hard to show work. I don't expect you to take a snapshot or something. Sorry. Yeah, that's kind of, you can't really do it there. Okay, I'm afraid we got to move on. Wow, almost a half hour. Okay. Yeah, you know, this reminds me, we need to do a problem, even though we've spent a fair amount of time on this questions. By somebody asking me that completing the square question, it reminded me of something that's we should probably bring up today. I don't. Maybe if I've done this already, would you tell me? I have a feeling we may have done this, but anyway, I know I did it with the pre-calc class. That is using completing the square in a more general case. So given the general quadratic equation, which is here's the general case where we don't know the coefficients a, b, and c. We just refer to them that way, but we do have the equation set equal to 0. Okay? Let's solve this using completing the square. I like this exercise because it does a couple things. It makes sure you really know how to use completing the square, and it gives a result that everybody in this room already knows, and so in effect you're developing it. So step 1, get rid of the c, just like we were doing earlier today. Subtract it from both sides. Step 2, we want to complete the square, so we really got to get a out of there. So divide everything through by a. Maybe just pause there. Is everybody with me on what I did there? The reason I had to get that a out of there is you cannot complete the square unless you have a coefficient of 1 on your squared term. We now have that. So now I can do the half of the b term squared thing, which we will do. Here's our so-called b term, b over a. What's half of that? What's half of b over a? b over 2a, I heard somebody say. Right. And what is b over 2a squared? b over 2a squared. b squared over 4a squared. Of course, I've got to do that to both sides. This now is a perfect square trinomial. And so it could be written as square root of this, square root of this, okay, now we have a little bit of a mess on the right. In this regard, I'd like to add those together, but they don't have a common denominator. So we can remedy that by taking the first fraction and multiplying it top and bottom by 4a, couldn't we? Because then it would be minus 4ac over 4a squared. And then we'd have a common denominator. Does everybody see that? So what I'm doing is this. Top and bottom, we're multiplying by 4a. Will that not give me 4a squared in both cases? Yes. So I could write this as one big happy fraction. Do you see where I got that? Isn't 4a times minus c minus 4ac? Okay, now what do you do next? Take both square roots. So plus and minus. I can take the square root of the denominator, that's 2a, but I cannot take the square root of b squared minus 4ac, so I have to leave it under the root. And now just get x alone, subtract this b over 2a from both sides. And since it has a common denominator, can't I do this? And of course, famous result. You guys should be able to do that problem. So, you know, I've told my pre-calc guys this too. Given the general quadratic, ax squared plus bx plus c equals 0, use completing the square to develop the quadratic formula. That's what we just did. Everybody follow the steps? So it's a good completing the square exercise, and it's the kind of thing that people in pre-calc and calculus should be able to do. Okay. Now, lines. Okay, let's see what I can do. This is, again, pretty basic, but extremely important. Should ask. Anybody questions on what's up there? Okay. Well, straight lines. Let's see. First of all, the straight line equation that I will aim everything towards is the slope-intercept form, which is that y equals mx plus b form. I'm pretty sure all of you have seen that in the past, where m literally is the value of the slope of the line, and b is the y-intercept. Okay. There are other forms in the book. They talk about the point slope form. They talk about the general form. They're all nice. You only need one. So I'm going to just teach toward the slope-intercept form. You can do all of, and by the way, I'll tell in advance, I don't remember, if there are any problems that say, put your answer in this, and then they maybe ask you for the point slope form, I just prefer if you just go for the slope-intercept form every time. So you can actually ignore the directions if they come up like that. Anyway. Okay. What's the formula for slope? How do you find slope? Rise over run. How else could we state that? That is certainly correct. I just want to get others, so let's just put that down. How else? Anybody remember a formula?
X2 minus y1 over x2.
Yep. If you have 2 points, x1, y1, x2, y2, wouldn't it be? Yeah, it's the change in y over the change in x. Very important that you get your y's on the top and your x's on the bottom. Common mistake, people get those inverted, and then of course everything is completely messed up. So, just the change in y over the change in x. All right. General things about slope. What kind of a slope does a horizontal line have? No slope, or 0. And what kind of a slope is it that goes from left to right in an uphill direction like this? Positive slope. Negative slope. Undefined. Yeah, because when you do this, what's the change in x going to be? If it's truly vertical, the change in x will be 0. You've got division by 0. And of course, that's basically an algebraic swear word. You can't do that. And so I don't want you to be slanderous, so make sure, or blasphemous, excuse me. And so we don't want to do that. All right. Let's see. Okay, what's true about the slopes of parallel lines? If two lines are parallel, what's true of their slopes? They're equal. What's true of two lines that are perpendicular? A little bit more. They're reciprocals and the opposite sign. Exactly. I always just say negative reciprocals. Just make sure that it's the opposite sign. So if a line has a slope of 1/3, what would be the slope of a line perpendicular to it? -3. Exactly. Well, those are basic. I knew you guys had that, so let's just dive into some problems. So on page 33, it says, first of all, visually estimate the slope of the line. 1, 2, 3, look at number 2. How do you visually estimate the slope of a line? Well, you don't just go, yeah, 2. You want to try to pick out 2 places where it crosses the grid, and then just find what's the change in y over the change in x. So, for example, I like the way it goes through the point 2, 0, then it also goes through the point 3, 2, doesn't it? So between those 2 points, what's the change in y? 2. What's the change in x? 1. 2 over 1. Slope is 2. It's still an estimate because, what if our eyeball's a little off? It's not perfect, but that's... So rise over run can be eyeballed. Then you got an easy one like number 3, because it's horizontal. That one you know right away, eyeball has to be a slope of 0. Okay, then, 5 through 16. Instead of a graph, we give you the points. Find the slope. That's asking if you can use the slope formula. Shouldn't be very hard. You got to do a little subtracting and a little bit of a dividing. Please simplify. Again, I do not like decimal answers here. So you want to leave things in fraction form because they show rise over run. But do get your fractions simplified to the lowest terms. Okay. Number 17 through 24 says, use the point on the line that they give you and the slope to find 3 additional points. Let's do one of those. Well, 18 is pretty wimpy, but let's just take a look at it. They give you the point -3, 1, and they tell you the slope of the line is 0. Can you give me the coordinates of, well, just give me one other point. Well, what does the slope of 0 mean? That it's horizontal, and doesn't that tell you that all the other points have exactly the same y coordinate as that one? So it's like, isn't it like anything comma -1? And all you'd have to do is pick 3 of those. So that one's pretty simple. But what about 22? We got the point 10, -6. We're given a slope of -1. So how could I find another point that's on that line? Well, from the anchor point that you have, how could you think of -1 as a fraction? Think of it as a fraction. Give me a fraction that equals -1. -2 over 2. So what does that mean? -2, that's the change in y. So down 2 over +2. Now down 2 to the right 2. Okay, what's a point that's down 2 and to the right 2 from 10, -6? Wouldn't it be 12, -8? And then you could go on and find. So that's how those are. The next one, find the slope and y-intercept if possible. The reason they had to put that in there is because you might have one of these undefined things, and then that would mean you could not find the slope. By the way, if you want to use, for undefined, it's okay with me if you use UND for an abbreviation. I've had people in the past who said there is no slope, so they wrote 0 down. You don't want to do that because 0 is a legal slope, and that's this guy. And undefined is not that guy. So make sure you don't, just use undefined, UND. So how do you find the slope in number 26? Given 2x plus y equals 40, how in the world are we going to find the slope? You said subtract 2x from both sides, and now you will have gotten into that slope-intercept form, and now what is the slope? -2. You can see it sitting there on the x. So you got to get it into that form though, right? Solve for y. Okay. How about number 31? You know, and this brings up a general thing. Generally speaking, when x is equal to a constant like that, what kind of a line do you have? Notice there isn't even a y in there. That's a vertical line. That's saying, I don't give a rip what y is. X is always, in this case, what, 4? So it's like 4, 2, 4, 9, 4, 10 trillion, 4 anything. And so what you got is all these points that line up and going through the x-axis on 4. So what's the slope going to be? Undefined. How about the slope on number 34? When you put that in slope-intercept form, what do you get? You just get y equals -1. Isn't that like really y equals 0x minus 1? And so the slope is 0. Yeah. So another little, so x equals a constant, what do those guys look like? Vertical. Y equals a constant, what do those guys look like? Horizontal. But this one has a slope, 0. This one doesn't. Undefined. Next section, write an equation of a line that passes through these 2 points. Where do we go with that? So if we were doing number 36, how would you begin? Find the slope. And to do that, you use the slope formula. y2 minus y1 over x2 minus x1. But now comes a question, which point is 1 and which point is 2? Answer, doesn't make any difference. Just so you don't change your mind halfway through. Stick with it. You know, why is that? Because what's going to happen is the signs on both top and bottom will change. So if the answer was like 1 over 2, and if you did it the other way, you get -1 over -2, well, isn't that still 1 over 2? So it does not matter which order. Just stick with. Okay. Page 34. Write an equation of a line that passes through the given point and has the given slope. So this time they're giving you a point and the slope. Okay, let's talk about one of those. And let's take one with a little bit of a challenge, like number 55. How would you do that problem? We have the point that it goes through 0, 2/3, and we know the slope of the line is 3/4. What would you do? First, write out. Remember, where are we headed? We're headed for y equals mx plus b. What have they already given you? M, so stick it in there. What's the only thing you don't know? Here, I'll quick write that one out. So, well, I forgot, where were we? Number 55. So we know this much already. What did we have there? 3/4. So, and then we know this point, 0, 2/3. How can I make use of that point to find b? Isn't this an xy coordinate? So substitute this in for x and this in for y, and you should be able to solve for b. So 2/3 goes in place of y. 0 goes in place of x. This is a really easy one. We got it now, 2/3. So now, what's the equation? Just take this one, rewrite it, only this time, put your b in there. That's supposed to be 2/3 down there.
Isn't your fee always gonna be the Y? Or not?
Well, only when the x-coordinate is 0. No.
When it's 0, though.
When this is 0, yeah, because isn't this the definition of a y-intercept? Isn't a y-intercept a point that has 0 for its x-coordinate? Yeah.
Right.
So yeah, you're right. If I'd have looked at that and gone, hey, dang, there's my y-intercept, I'd have been done. But of course, if this was 3, 2/3, we would have had to do some multiplication, some subtraction, and pretty easy though. Yeah, good observation. So really, that was a pretty wimpy problem too, wasn't it, 55, because they really handed you, yeah. Well, I think we've at least taken a pretty good look at a sampling. Let me quick remind myself what the assignment was. Every other odd, with 99 being the last. You know, we do have just a couple minutes, and something I never talked about last time. At least I didn't talk about it yesterday. And that is, you'll have a couple problems that will have revenue and costs in it. And remember, R stands for revenue, C stands for cost. And if they ask you about profit, remember, profit, you got to take your revenue and subtract your costs. So there might be some applications with lines of that type. Okay, thanks. I hope you have a good weekend.